Welcome back to Textbook Toonz. Today, Rohan has finally reached the inner perimeter of the bazaar of numbers. Before him stands a vault that requires more than just force to open. It requires a specific numerical result. The interface displays the specific algebraic lock we must solve. In algebra, x acts as a placeholder, a container for a value we haven't identified yet. The vault won't open until we can determine exactly what is inside that container. A message from the grand mathematician clarifies the exact key. This is the starting point for our process. We are now going to evaluate the expression by replacing the variable with this specific value. Think of it like a technician swapping out a generic component for a high-performance battery. Because x is exactly 3, we can remove the letter and seat the number 3 into that position. But simply knowing the value isn't enough. If we don't follow the correct mathematical protocol when inserting the number, the system will fail to process the result. This is where many calculations go wrong, dropping the number into the expression without any formatting. Without formatting, our term morphs into 43. The vault system detects a logical error immediately. In algebra, placing a number directly next to a letter signifies multiplication. It doesn't represent tens and units. By just sliding the 3 in, we fundamentally misread the relationship between the numbers. To maintain the original logic, we use parentheses. By encasing the 3 in these brackets, we preserve the syntax of the expression. These parentheses act as a clear command for multiplication, ensuring the relationship between the 4 and the 3 is handled correctly. Now we follow the order of operations. We multiply before we add. 4 times 3 gives us 12. Finally, we add the 7. Our result is 19. With the correct value calculated, the first layer of the vault door releases. Brackets are the primary tool for variables. They ensure that the rule of multiplication is perfectly preserved when you translate algebra into arithmetic. Moving deeper, the security interface scales up. The holographic grid displays a trickier, multi-layered polynomial trap. The input for this section is a negative value, x equals -2. Negative numbers introduce another layer of complexity. If we aren't careful with our signs, the entire result will be incorrect. We remove both instances of x and replace them with -2. Notice that the bracket protocol is applied to both substitutions to keep the negative signs isolated. We start with the exponent, -2 squared. Since a negative multiplied by a negative results in a positive, -2 squared becomes +4. Multiplying that by the 2 in front gives us a total of 8. Next, we look at the second part of the expression, -5 multiplied by -2. When we multiply these values, the two negative signs interact to form a positive result. -5 times -2 becomes +10. We combine our results, 8 plus 10, for a final value of 18. The lasers deactivate and the path is clear. When handling negative variables, brackets function like an isolation chamber, allowing you to resolve signs independently before combining them with the rest of the equation. Evaluating an expression is a systematic process. Swap the variable for a number using brackets, then calculate the result following the order of operations. At the center of the vault sits a golden chest. To reach what's inside, there is one final task displayed on the holographic chalkboard. The grand mathematician has left this final challenge for you to carefully solve using the specific numerical parameters displayed on the board. Apply the bracket rule, perform the calculation, and share your final result in the comments below. Mastering these steps transforms math from a series of confusing hurdles into a logical, predictable system. We will see you in the next chapter.